What's going on, guys? Mr. Garcia here. Got another video. This one's starting module 2. Section 1 is all about the 3 E's, apparently. Expressions, equivalence, and exponents. Oh my. All right. Factoring and multiplying are big here. And then there's some law of exponents that are super important. This is needed for the rest of our content, especially in module 3. Not so much module 4, but especially module 3. Couple different ways to approach multiplying. Distribution property is all that's happening. So if you like the FOIL, some people call it, where you do the first times the first, and then first times the outside, and then you do inside times the first, or I guess last times the last. That's great. That's awesome. I'm not going to do that in my videos, but if you want to, please do it. Knock yourself out. I like to multiply with the box method. It just, I don't know, from a visual standpoint, it just like makes my life so much easier to see. When you think about the box method, all we're really doing is finding the area of these boxes. So we have a 2x2 box where you have the expression 2x plus 3. We'll put that on one side, and 3x minus 1. It doesn't matter what side you put it on. With multiplication, you can swap them as many times as you want because it's commutative property. If I ask you to find the area of these 4 boxes, it's almost like a throwback to freshman year biology class, Punnett squares, right? This box is 2x and 3x. This one is 3 and 3x. Here we have -1 and 2x and -1 and positive 3. This is still the distributive property, but now it's just organized. That's it. So 2x times 3x is 6x squared. The 2 and the 3 multiply, and the x multiply. 3 times 3x is just 9x. 2x times -1 is -2x, and -1 times 3 is -3. What I just multiplied was 6x squared plus 9x minus 2x minus 3. We should notice that, hey, we have like terms we can combine together. Only those with the same amount of x's, or really the same amount of variables, can be ones that combine together, which is just the 9x and the -2x. So for us, it would work out to be A. Now we see something like number 2, factoring. Factoring isn't going to be too bad for us because a lot of times, not always, but a lot of times, we're finding 2 numbers that do the following: that multiply to be 20, or the last number, and they have to add up as well to be -9, or the middle number. So 2 numbers that multiply to be the last one and add up to be the middle one. So a couple of different ways to approach that. One way is to say, well, there's a lot of numbers that add up to -9. But there's not that many numbers that multiply to 20. So let's make a list of numbers that multiply to 20. 1 times 20, 2 times 10, 3 times, 4 times 5, 5 times 4. Oh, wait, that's still the same thing as 4 times 5. So we're kind of done there. Now we do notice they're going to also add up to be a negative. But how can they add up to be a negative and still be here? Well, do notice a negative and a negative still multiply to be a positive. Same thing for all these. From there, we have a list of 6 possible options. That narrows it down a lot. One of these options has to also add to be -9. So if you add these lists together, 1 plus 20, 2 plus 10, 4 plus 5, so on and so forth, the only numbers that would work would be -4 and -5. Now, with factoring, we are rewriting this expression to be x minus 4 and x minus 5 because those 2 numbers multiply to be 20 and added to be -9. I do want to connect the fact between these 2 things here. These were the factored form, and they multiplied to be this, often called the standard form. In a box, this was the outside, and this was the inside. Whenever you have the opposite. When you're factoring, we're effectively saying this. We now have the inside part, x squared 20, and these middle two, these middle two here have to combine up to be -9. And then you can see, that part on the outside would be your factored form. I'm saying that to say this. If you struggle with factoring, here's one thing you could do. Just rely on this. It's an untimed test that has multiple choice for every single question. If you multiply these two out using your box, using your FOIL, using your whatever, and it doesn't work out to be x squared minus 9x plus 20, that's not the answer. Same thing here. Doesn't multiply to be this. Doesn't multiply to be this. This one, if you multiply it out, and I'll show you here real quick, x minus 4 and x minus 5, notice that in this case, -4 and -5 do add up to be a -9. Using your answer choices to your benefit is always wise. And last thing, you can also avoid this list. If you're trying to figure out which two numbers work, they're kind of giving you some options here. So they kind of just told you which numbers multiply to 20. Thank you. Now, which option also adds up to be a 9? 4 and 5 gets you positive 9. Great. -2 and -10 get you -12. That ain't -9. -4 and positive 5 get you a positive 1, which definitely isn't here. -4 and -5 get you there. So before we move on to the last two questions, just to recap. 3 different ways to approach factoring on the TSI. One way, just factor. Just use your typical Algebra 2 factoring methods that you learned in Algebra 1, Algebra 2, and commit to it. Option 2, in your answer choices, just multiply each one out and see which one gets your expression. Or option 3, it's a mixture of the first option, where your numbers that you're trying to find are just the ones that are given to you. All 3 methods will always work. You just got to pick. That's where the practice comes into play. All right, number 3, simplifying expressions. We have exponents. So there's a couple things happening here with your exponents. Product rule, quotient rule, and power rule. So these rules are just kind of like shortcuts almost to all this information. I'm going to show different ways to approach these as well. So if you don't want to do this, that's fine. For example, if you don't want to memorize this, if you're multiplying 2 things together, x to the 4th times x to the 5th, I'll say that. We're essentially asking how many x's do you have altogether? Well, x to the 4th means you have 4 x's. X to the 5th means you have 5 x's. So in total, if you sit here and count them all, you would have 9 x's. Now the shortcut is just saying, hey, you could have just added 4 plus 5. Great. Amazing. Awesome. Same thing with division. If you wanted to do that same idea, x to the 5th divided by x to the 4th. 5 x's on top, 4 on bottom. You would notice that they have some x's in common, and you have only 1 x left over. Your answer would be just x. Or you could have also you could have subtracted these two to be here. And then finally here as well, power rule, and that's where I'll start off. One way to approach the power rule is to say, well, the power of 2 is with all this stuff here. I mean, the power of 4 only is with the x. The 3 is only with this y. But this power of 2 is everything in the parentheses. And we know the power of 2 just means that it multiplies by itself. So we're taking 3x to the 4th, y cubed, and multiplying it by itself 2 times. And now this starts to become like the product rule, where you have x to the 4th, 4 x's, and x to the 4th, another 4 x's. So in total, you have 8 x's. Same thing, you have, 3 y's here, so y cubed, and another 3 y's here, so you have y to the 6. And then you just get 3 times 3, which is good old 9. Now, you could just use the little shortcut. If you have an exponent to exponent, just multiply. 3 times 2 gets you 6. 4 times 2 gets you 8. Just be careful. The 2 also goes with your 3. It's not going to be 3 times 2, though. It's 3 raised to the power of 2. So just be super careful there. So in this case, it worked out to be, is that C? C. Number 4 is a good example of using the quotient. Yeah, mainly just a quotient. One thing to note here, we multiplied your variables or your coefficients in front because the operation was multiplication. Crazy, right? Same idea here with the 10 and 15. We are dividing 10 and 15. Nothing changes there. So if I ask you to simplify that, you would maybe divide both the top and bottom by 5, and you'll get 2 over 3. So your answer better have 2 up top and 3 on bottom. So now we're left with between B or D. Do the same idea with the x's. 7 x's on top, 2 on bottom. You have, I'll do this here. You have 5 left over. You can also, in that case, just subtract. That's fine. Be careful when you do your subtraction rule, though, because, whoa, if we did this, you would have -4, which is still mathematically accurate. We don't cover the rule for negative exponent here. So if you are curious about the rule, I'm about to explain it right now. If you do not care for it, then skip ahead 10 seconds, okay? The rule is, if you have a negative exponent, to make it a positive, you take its reciprocal, as in, hey, the part with the negative just moves to the opposite side of the fraction. Okay? If you skip that, great, awesome, you didn't miss much. Another way to avoid using negative exponents is to say, well, you got 2 y's on top and 6 y's on bottom, and we know 2 of them cancel out, so you're left with 4 y's, but the 4 y's are on the bottom of the fraction. So just be careful there. We are starting to get our answer already, but you can verify it with z's because you got 10 up top, 4 on bottom, and 10 minus 4 definitely gets you a 6 last time I checked. I definitely recommend to do the practice over this stuff. Be comfortable here. This is huge for you in this module and the next. Hope you have a great rest of your day. As always, if you have questions, reach out. If not, have a great rest of your day. And as always, go Mavericks.